The next part of Section 3E talks about polygraphs and drug tests. With both of these things, there is the potential for the test to be wrong. For example, the following table is based on the assumption that 1% of breast tumors are malignant, which means that they are cancerous. However, this table assumes that a mammogram screening is only 90% accurate. So, if we have 10,000 women that go in to get a mammogram, we want to figure out what pieces of the table we can get from this. We know that 1% of breast tumors are malignant. So if we've got 10,000 people that come in, we should have about 1% of them that have malignant tumors and 99% of them that do not have malignant tumors. So for our first box here under total, we know that this is going to be 10,000 people times 1%, or 0.01 as a decimal, and that comes out to be that 100 of the tumors will be malignant. Well, if 100 are malignant and 10,000 are detected, then that means that by subtracting we can get 9,900 are benign. Benign means that it's not necessarily cancerous. We could have also found that by taking the 10,000 and multiplying it by the 99% of breast tumors that are not malignant, or they're benign. Now, when the problem tells us that the mammogram screening is 90% accurate, it means that when a tumor is malignant, it will catch that malignant tumor 90% of the time, or we'll get a positive mammogram test. Whereas if the tumor is benign, we should also get that 90% accuracy rate, and the woman should get a negative mammogram reading. So in the upper left-hand box, we've got a 90% chance of detecting the tumor. Well, if there were 100 tumors and 90% accuracy, we can multiply the 100 by 0.9, and we end up finding out that we should detect or get a positive mammogram on 90 of the 100 women that actually have a malignant tumor. Well, then for negative mammograms, if we had 100 females that do have a malignant tumor and 90 of them test positive, that means that 10 of them will test negative. Again, similarly, since this is a 90% accurate test, if the tumor is benign, the mammogram should come up negative. So of these 9,900 women that have a benign tumor, 90% of those should come up as a negative mammogram. And multiplying this, we end up getting then that 8,910 will come up as a negative mammogram. Now, as we have been doing, if we know that 8,910 will be benign, and we had a total of 9,900 that were benign, but the 8,910 came up negative, we can subtract to figure out how many will come up positive. So we end up getting a solution here of 990. And again, that's found by taking 9,900 and subtracting off 8,910. Lastly, what we can do is go through and figure out the total number of positive mammograms and the total number of negative mammograms. And to do that, we can just add the total number of tumors that were malignant that came up positive and tumors that were benign that came up positive. And we end up getting 1,080 positive mammograms. And again, only 90 of those really had a tumor that was malignant, whereas 990 of them did not. In the same way, we can go through and add the values from our second row here, the 10 for the negative mammogram when the tumor was malignant, and the 8,910 when the tumor was benign, and this gives us 8,920. Or we could have taken the 10,000 women that got mammograms and subtracted the 1,080 that we found above. Next, we will use our table to answer the following questions. For example, suppose a patient has a positive mammogram. What is the chance that she really has cancer? So what we need to look at here is those that had positive mammograms in our table. So we can see here that there was the 90, the 990, and in total 1,080. So the fact that it says suppose a patient has a positive mammogram, we only want to look at that row of the table. What we want to then determine is what's the chance that she really has cancer. Well, what we can see from the table is that 90 patients actually had a malignant tumor out of the 1,080 that tested with a positive mammogram. And if we divide that, then we end up getting an answer of 0.083. Or as a percent, there's an 8.3% chance. Now what that means for you is that if you go to the doctor one day and it comes back as a positive result, there really is only an 8.3% chance that you have the malignant tumor, assuming that we do have a 90% accurate model and that only 1% of breast tumors are malignant. But it's something that you should ask your doctor if you ever run across this situation. A similar but slightly different question is, what's the chance of getting a positive mammogram given that the patient has cancer? For this question, we need to look at the column where it says that the tumor is malignant. So we're looking at this column here. And it says, what's the chance of a positive mammogram? So that's looking at these 90 patients that had a positive mammogram, divided by the 100 that actually had a malignant tumor. And this comes out to be 0.9 or 90%. This is going back to our accuracy statement where we said that 90% of our mammogram screenings are accurate. Lastly, we want to look at patients that had a negative mammogram. So suppose a patient had a negative mammogram. They fall into this row. We want to figure out the chance or the probability that she actually does have cancer. If she has cancer, again, remember that she has the tumor that is malignant. So 10 of our negative mammogram results come from having a malignant tumor, divided by a total of 8,920 people that would end up getting a negative result. And when we divide this, we end up getting 0.0011 or 0.11%. So, if a patient has a negative mammogram, the chance that she actually does have cancer is less than 1%.